So your first homework due on Monday the 31st. And I'm going to ask if everyone puts themselves on mute so you can kind of focus. I've got the, so you can unmute if you want to ask a question related to the material, or I have the chat on the side if you want to type a question. Let's see. So I've asked the statistics coordinator a few of your questions, and I have an answer to just one of them. I still need to find out exactly how much your homework account will cost. Where is the best place to buy it? And do you need some kind of ID or code? Also, someone asked, do you pay out of pocket? Unfortunately, yes, it is something you have. I'm asking for you to pay for. I don't have a free code this semester. So I did find out that a few students in other stats classes, including ours, were charged $65 by the bookstore for a stat fee, and that was a mistake. So that charge should be removed. Students in my last class said it was removed yesterday. But if you still have a $65 charge, you would need to contact the Boursoir's office to have that removed. I'll share it as an announcement on Canvas. So just a note for people who asked, only some students were charged this amount. If you need help checking if that happened to you, visit my office hour and we'll look at that together. So it was just some kind of miscommunication that happened between Pearson and the school, but it's being fixed. Okay, let's go ahead and do notes. So we're still in section 1.1. Before we get started, I just want to kind of tell you that through the semester, it won't feel much like a math class. We need to learn a lot of vocabulary, understand all these definitions, do some organizing. And when we do that organizing, that's when we use math. So a lot of the times it's a lot of writing and vocabulary, and then sometimes we use math techniques to further understand our question. Okay, 1.1 is statistics basics. Last time we had an example. I'll go ahead and put the example back on the board. So we did this last time. A study is done where 2 adults are selected from each of the 50 states, giving a total of 100 people in the study. And I asked for you to try to find the population, but we're just going to put that down right now. Population. So we're picking adults from the United States. So the idea is our population would be all adults in the US, all of the adults in the United States. Okay, and then you see there's like 2, and you're selecting those 2 each from the 50 states, and then you have this total. The total of 100 people in your study is your sample. Okay. We're going to do our next example where of the California population. Let me see, I got a little thing in the notes here. Oh, cool. So someone's just asking about missing class, and don't worry about, if you like leave a class early or you miss a class, because I record each class and then I post it to Canvas. So attendance won't affect your grade. And if you want to look at the notes, they're recorded and posted week by week. So it's in the, Monday's notes are in the modules for week 1. And then I'll upload today's video to YouTube tonight, post it tomorrow in that same module. Okay. California population, a survey of 2,000 randomly selected adults. Also on the side, before I keep going, if you're just now joining the class, like if you added the class or something happened earlier this week, you can also just stay after and talk to me, and I can help fill in the gaps of like what we went over on the syllabus or what the important things are to know about Stat1-37. Resulted in 34% having an allergy. And a population is the whole set that you're interested in. A sample is a subset or piece of that set. Of the California population. Okay. So our population is all adults in California.
Professor,
Yeah.
I'm sorry. So when you say all adults in California, it doesn't read the word all in here. So how do you know? Okay, so I've always had a problem with word problems. I don't know if anyone else in class has. Always struggled with word problems. So like to find out the population, like it sounds so easy that it is all the adults, but how is it that you really like, is there a word or a phrase or something that you have to kind of like figure out to know like, okay, that is the population because it's like all of the adults or anything?
um, I just want to first mention that I also still struggle with word problems, and that's okay. And then I would say it's sort of a habit that you put this word in here, and like you kind of need to know that you're looking for all of the things that you're interested in. So almost every time that you're asked to find the population, you start with this like all something like maybe the problem says I select 20 fish from a pond to observe their color, and then you need to ask what's the population, what's the sample, and then even though it says 20 fish, you would say the population is all fish in the pond. So you kind of put that word in there, and then the sample is the 20 that I picked out. I think what will help is maybe some extra examples. So after this one, we'll do another one or two.
I keep on forgetting that I'm on mute, but thank you. I was saying perfect. Thank you.
Oh, okay, thank you. Yeah, and also I'll keep on going if I don't know. All adults in California. Thank you for asking questions. It really helps with the lecture. So this is kind of the piece you pick out from the problem, and this part you sort of add as your answer, sort of with practice and also with using the definition. Sample's kind of easier. You can usually find this in the problem. The 2,000 randomly selected adults, that's the sample.
Why would it not be 34%?
34% is called a different thing, and I'll put that up next.
Oh, okay, thank
It's
you.
cool.
Sorry. Okay.
It's good to ask questions. Okay, so population is the whole group, and a sample is a part of the group. If you know a numerical summary of your population, that is called a parameter. If you know a numerical summary of your sample, that is called a statistic. And this 34%, adults, 34% have an allergy. 34% of the sample have the allergy. So this is called a statistic because it describes something about your sample. We don't have anything describing the population, so we don't have any parameters right now. We can write down what this is.
That made sense. Thank you.
Oh, yeah, of course. Thank you. So we're getting into this today, descriptive statistics and inferential statistics. It turns out this is a descriptive statistic, And again, I'll put that definition down soon. But not only is this a statistic, because it's a number related to the sample, but it's also a descriptive statistic because it just summarizes, it's just a summary of the sample. So we went over this definition. This makes it a little bit more specific, and I'll explain what a descriptive statistic is in today's class. It summarizes information about the sample. Okay, so I'm going to go ahead and make up one or two examples to get practice on how to find your population and your sample. I'm actually just going to grab the book to see if that would help. So just a second. Okay, this one says in a study, 59% of Americans between ages 18 and 29. Oppose medical testing on animals. And it says the percentage of 59% was computed from sample data. Okay, let's see how this goes. All right, so for your population, well, I'm gonna add that extra little bit from the notes and enable. Yes, it says the percentage of 59% was computed from sample data. So in the book, part A is identify the population under consideration. So you could have put the word all, and it would be all Americans between the ages of 18 and 29. Okay, so for this sample, I don't know how many people were in the sample, but I do know the sample was some small group of Americans between the ages of 18 and 29. So be very specific, just to be clear, but you could just say the group of people that were in the sample or that were in the study. And those people were between the ages of 18 and 29. Americans. So I just have a comment on the side about audio. I'm going to keep trying to remember to talk to the computer when I'm talking. I'm sorry, I forget. But soon I'm working on getting a setup with a mic. So I have a mic that I'll practice with. Hopefully it'll sound good. Later this semester, I might buy a mic. I am teaching one of my classes part online. So I guess it would wouldn't matter for you if I didn't get it soon. I'm going to practice working on the audio and making it better to hear. And I'm going to stop there with examples. When we come up to test time, I will make a review, and it will have practice problems where you can practice finding population, finding the sample over and over again, and then I'll share the answers or have some kind of answer key. Okay, what we need to do is talk about the two types of statistics. First type is descriptive statistics. Descriptive statistics consists of organizing and summarizing data. So you have a group, a population, or sample, and just gather data that describes that group. We use descriptive statistics if we have all of the values in the data set. So you know everything about all the values in the data set. So you have a population in which you can collect information from every single person in that population. second kind is called inferential statistics. Okay. Inferential statistics uses methods that take a result from a sample and then extend it out to the population. We use inferential statistics when the population is too large to obtain all of the values of the data set. So with descriptive statistics, we can describe what is happening in that population because we have all of the information we need from that population. With inferential statistics, we can't collect all of the data from the population, so we collect data from a sample and then use the results from that to have an idea of what's going on with the whole population. So we just assume that what the sample shows is what the population would show. Just kind of infer that information. So it's like describing and inferring. You know what's happening, or you have an idea of what's happening. Okay, then we're going to go into two types of studies. One's not better than the other. There's just two different two different results. First is an observational study. You only observe and don't apply any treatment. So you don't influence anything, you don't apply any treatment. The other is called a designed experiment, where researchers impose treatments and controls and then observe the characteristics and take measurements. I'm not the best speller, so I kind of bring my notes with me, but I got this. R-E-S-E. Okay, impose treatments. And controls. So the control group is the group you don't affect, and the other group is where you do affect that group and give them a treatment. Oh yeah, so there's a question on the side. So this is a separate topic. So there were two types of statistics, descriptive and inferential. And now there's a whole new kind of topic where we're talking about two kinds of studies. So like in So like if you're doing descriptive statistics, you can pick one of these studies. Or if you're doing inferential statistics, you can do one of these studies. So we apply a treatment. So let me draw a picture. I hope it makes sense. But the idea is that descriptive statistics is separate from inferential statistics.
Professor, so I can pretty much decide if I want to do like so I can choose a descriptive statistics and apply like a study with like observational study. And if I don't want to do observational study, then I apply with descriptive statistics a design experiment, right? So it just
Yeah.
depending on how you want to use it.
Yeah.
Okay. Okay. Thank you.
And I think we're almost out of time. I'm going to go ahead and set up an example, and then we'll come back next time and talk about what kind of study we would do, or we talk about studies. So let's say the question is, do cars slow down at yellow lights? Actually, I think I'm going to use these last few minutes to try to finish this example, and then we'll go. Okay, so if I want to answer this question, I could do an observational study. So I would go to some kind of stoplight and pick a spot where the cars can't see me. And I record what happens that day as people come up to lights, the yellow light. So I'm over on the side collecting data. No one knows I'm there. So they just act as they usually would. And I haven't applied any kind of treatment or haven't affected them in any way. It ends there. On Friday, I hope we'll finish the notes for section 1.1. And then you'll be all set to do your homework. Okay, thank you everyone. Have a good day. See you later.